Hi, this is Mrs. Kidman, and in this video, we are going to be discussing how we can draw angles of rotation and find coterminal angles when we are given radians. So just as a review, when it comes to drawing angles, we're going to start by drawing some in degrees, just to remind us what we do, and then move on to how we do it in radians. So when it comes to degrees, we start by drawing our little axis here that goes 0, 90, 180, 270. Then we draw our starting side or our initial side. We draw our terminating side right where that 240 is, which is in between here. And we draw our arrow going in the direction that we go. Now, if it's positive, we're going to go counterclockwise. If it's negative, we go clockwise. And that's how we can draw our angle there. Then we want to decide which quadrant it ends in. And in this case, it ends in quadrant 3. Now let's take a look at negative 75. Now when it's a negative, we actually label it going the other way. So it's 0, negative 90, negative 180, negative 270, negative 75, we have our initial side, our terminating side. And when it's negative, we actually go clockwise with our arrow. And this one is going to end in quadrant number 4 here. Now, if we have something like 490 degrees, which is greater than 360, what we do is we subtract 360 to get it in between that 0 and 360 point. And we end up with 130 degrees. So then as we come to do this, this one is positive, so we're going in the positive direction, or labeling counterclockwise. And then we draw our initial side, our terminating side, and our arrow is going to go in that direction. But because we subtracted 360, we actually have to go around the circle one full time before we stop at our end. So this is just a review on how we can draw those angles given the degrees. Now, when we have angles like these ones are radians, however, rather than degrees. So we're measuring them in a different way. When we have something like this, what we want to do is we want to set up our axis the same way. Now this is 0 pi. It's also 2 pi. This is just 1 pi. This is 1/2 pi. We usually write it as pi over 2. And this is 3/2 pi. Okay, so in your mind, that tells you this is 1.5. This is 0.5, this is 1, this is 0. Now to figure out where our angle is going to go, we're going to start by drawing our terminating side, or our initial side here. And then we need to figure out where that terminating side is. Well, 5 pi over 3, we need to decide, is that between 0 and a half and a full and 1.5, or 1.5 and 0? Now, there's 2 different ways to do it. One way is to use our fractions to compare, but a really easy way is to actually change this into a decimal, which is just an approximation, but it'll tell us which value it's in between. So if we take 5 and divide it by 3, we end up getting 1.66 repeating pi, which is going to be between 1.5 and 0. So we draw our line there, our terminating side. We go ahead and draw our angle that goes around, and we know we end in quadrant 4. So we're going to do the same thing here with this pi over 6. We've got our 0 pi, our 1/2 pi, our 1 pi, our 3/2 pi. Now, pi over 6 is the same thing as 1/6 pi. So if we do 1 divided by 6, we end up getting 0.166 repeating pi, which is definitely between 0 and 1/2. So we've got our initial side, our terminating side, we have got our arrow here, and it ends in quadrant 1. So you can see how we can just switch these into decimals to give ourselves an idea of where it's going to end up. So that works awesome when they are positive. Now, if they're negative, we're going to do the same thing that we did when we had a negative degree. We're going to label it going the other way. So in this case, we're going to start with our 0 pi here. We've got our negative 1/2 pi here, our negative 1 pi here, and our negative 3/2 pi here. Now we're going to do the same thing as before. Negative 5 divided by 3 is going to be approximately negative 1.66 repeating pi. So when we go to draw this, we have our initial side. 1.66, it's going to be over here. Now we're negative, so we're going clockwise to draw our arrow, and we're going to end up in quadrant number 1. Beautiful. Now, what if we have something that is like negative pi over 12? Same sort of thing. We go through to label it. We've got our 0 pi, negative 1/2 pi, negative 1 pi, negative 3/2 pi. And then we want to figure out what this is. So if we do negative 1 divided by 12, we find out that that is approximately equal to negative 0.0833 repeating pi. So that is definitely not quite a half. So we have our initial side here, our terminating side there, we're going clockwise because our radian is a negative measurement, and we end up in quadrant 4. So we can see kind of how that works there with those. And that is how we can draw those angles anytime. So what you want to do is set up your quadrant here in terms of those different values, and then compare our fractions. And an easy way to compare fractions is to change them into decimals, which means we're taking them and making them out of tens, hundreds, or thousands, rather than having them as different denominators, so we can easily compare them and decide where it goes. Now, the last thing we want to talk about are coterminal angles. Now, we want to discuss these coterminal angles because they're angles that are in the same place. Now, right at the beginning of the video, we talked about how we have 490 degrees and how we could subtract 360, which is the distance all the way around the circle, to get to another place that's the same. And it affects the way that we draw our angle there because we add those extra loops. So what we want to do is use these coterminal angles, or an angle that's in the same place but takes a different number of trips around the circle. And we want to be able to find these, so when it comes to sketching a picture of the angle or figuring out where they are, we can decide that. The way that we do that is we need to go all the way around the circle. Now, when it comes to degrees, all the way around the circle is 360 degrees. When it comes to the number of radians, it's actually going to be 2 pi to go all the way around the circle there. So what we want to do is we need to add 2 pi, but just adding 2 pi here isn't easy, because remember, anytime we're dealing with fractions, we need to add something with the same denominator. So what we actually want to do is to figure out a positive and negative coterminal angle, we need to either add or subtract 2 pi, but I want to do 2 pi in a special form. What I want you to do is I want you to take the denominator and multiply by 2. So that would be 6. We're going to leave our denominator the same, and we're going to add on a pi. So 6 pi over 3 is the same as 2 pi, right? So what we want to do is we actually want to add 6 pi over 3 to get a positive 1, and we want to subtract 6 pi over 3 to get a negative 1. So a positive coterminal angle here would be 11 pi over 3. If we wanted to get a negative coterminal angle here, I would take my 5 pi over 3, and I would want to subtract 6 pi over 3. And if we subtract 6 pi over 3, we end up getting negative pi over 3. And there we have our coterminal angles. Now, unlike with degrees, where it's always add or subtract 360, with these radians, we need to add or subtract 2 pi, but we want the 2 pi to be written in the form where it has the same denominator. So we're going to practice finding some coterminal angles here by finding a common denominator. So in this case, these ones are still a denominator of 3. So that means 2 pi is going to be 6 pi over 3. So we want to add 6 pi over 3, which gives us 8 pi over 3. And we want to subtract 6 pi over 3. And 2 minus 6 is negative 4 pi over 3. So those would be our positive and negative coterminal angles there. Now with a question like this one, our negative 17 pi over 6, 2 pi, if it's going to be out of 6, is going to be 6 times 2, which is 12 pi. So we want to add 12 pi over 6. And when we do negative 17 pi plus 12 pi over 6, we end up getting negative 5 pi over 6. Now that one is still negative, so I'm just going to take that and add 12 pi over 6 one more time to our negative 5 pi over 6. And that gives us a 7 pi over 6. So we can see this 7 pi over 6, negative 5 pi over 6, and negative 17 pi over 6 are all coterminal. So again, anytime we need to add or subtract 2 pi, I want you to change it. So anytime we need to add or subtract 2 pi, I want you to find the denominator. We want to make it the same. Right? So we're going to divide by 3, or divide by 8, or divide by 129, whatever it is. Then we are going to multiply our denominator by 2 and make that the numerator with our pi symbol there. So this would be 6 pi, this would be 16 pi, and this one would be 258 pi. Okay, it doesn't really matter, but that's what we want to do. And then we can add or subtract that to find that coterminal angle. Now the last thing to deal with our coterminal angles here is we want to decide whether or not angles are coterminal. To do that, what we want to do is instead of adding or subtracting, we want to see if these can be added or subtracted. So we want to look at is 43 considered a multiple of 2 pi if we add or subtract 2 pi from 7 pi over 9? So 2 pi, in the case of 7 pi over 9, we want to use the 18 pi over 9 situation there. So we want to see, can I add or subtract 18 pi over 9 to 7 pi over 9 and see if we get to 43 pi? Well, let's go ahead and take a look here. If I take my 43 pi over 9 and I subtract 18 pi over 9, I end up getting 43 minus 18, 25 pi over 9. Then we can try subtracting it again. If we subtract 18 pi over 9 from that, 25 minus 18 gives me 7 pi over 9. Now, because I could subtract 2 pi, so this is minus a 2 pi, this is minus a 2 pi twice, and I got 7 pi over 9, that means that these are coterminal angles. If we were to sketch a picture of them, 7 divided by 9 puts us right in between a half and a whole pi. So if we were supposed to sketch a picture of this, we would actually end up being over here, but with 2 full rotations. So this one would end up looking like this, versus the green one, which is just our 7 pi over 9, which would look like this. Okay, so 2 different angles, but they end up in the same place. Now, what about these other 2? If we want to check these, our 2 pi, because our denominator is 9, 2 pi in this case is still going to be 18 pi over 9. So what I want to do is I'm going to go from 16 pi over 9 and try to add 18 pi over 9 to see if I can get to 35 pi over 9. Well, 16 pi over 9 plus 18 pi over 9 equals 34 pi over 9. And if I add 18 pi over 9 one more time, then we end up getting 52 pi over 9, which puts that 35 pi over 9 right in between the 2. So these ones are not coterminal angles. They're close, but they're not quite there. So we can see kind of how that works there. What we want to do is we want to take our 2 pi value, change it to have a common denominator, and then either add 2 pi or subtract 2 pi repeatedly until we either reach the other angle or we go past it and realize that that's not actually coterminal. If you have any questions, don't hesitate to reach out, but that is how we can sketch pictures of angles in standard position, whether they're given to us in degrees or radians, as well as finding coterminal angles.